But the first thing is the determinant. The determinant exists for square matrix. And what a square matrix means is the rows and columns are exactly the same. So it's 2 by 2, 3 by 3, 4 by 4, whatever. And so the determinant will only exist if that's the case. And the determinant can be used to identify whether a system of equations has a solution or not. It has a couple other applications that are built into some other calculations. But we're just going to kind of work with the determinant as it sits by itself. Okay, so let's say we take a square matrix A, B, C, D. So this is a 2 by 2, and we want to find its determinant. The way that you find the determinant is the determinant winds up being the difference of the kind of diagonal products. So if you take the diagonals, A times D, and you take the difference between that and the diagonals, C times B, that's going to give you the determinant. So if we took, let's say, an instance of this where in this 2 by 2 we have the following. Okay, so see if you can find what is the determinant in this form. Okay, you should be able to mentally calculate this. The product of our diagonals moving down and to the right is 3 times 4, up and to the right, so we're going to subtract a 1 times negative 2. And so if you look at that, 12 minus a negative 2 gives you 14. Okay. When you write determinants, you might see it set up in this form, the determinant of the matrix. The shorthand version of this is if you see a matrix set up with no brackets, just what looks like absolute value symbols, okay, that stands for the determinant. So this is equivalent to saying the determinant of A, B, C, and D. All right, so for 2 by 2 2 by 2 matrices, it's not a big deal. You should be able to find the determinants. Okay, what I would like you to do is I'm going to open up the homework on page 218. I want you to do questions 12 through 20. Easy up till now, right? All right, let's talk about a 3 by 3 determinant. Okay, when you're looking at a 3 by 3 matrix and you're finding the determinant, okay, the way that you set this up to find it is, again, if we write our determinant using the bars, A, B, C, D, E, F, and G, H, and I. So you might see this written in your book. Okay, in order to complete the form for following these, what you're going to have to do is just continue the cycle, okay, of the first 2 letters in each of these, or in the matrix itself. What this is going to allow you to do is draw your diagonals up and down to get the entire products that you're looking for. Okay, so after you repeat that cycle twice, what you can then do is you're still taking the difference of these products, but you're going to move down. So you have to take A times E times I. You're going to add that to B times F times G. And then you're going to add that to C times D times H. Okay, so here's the first quantity. Okay, and you're going to subtract. You're taking the difference of that quantity versus the quantity that's achieved by moving up. So now you go up, G times E times C, plus H, F, A, and plus I, D, B. So when you look at this, if we were to take an example of this set, okay, if I asked you to find the determinant of, and I gave you -4, 0, -1, 0, 8, 9, and 0, 5, 2. If you were working through to solve this, what you're going to do is set up your vertical bar to represent the determinant. And then you're going to duplicate your first two columns. So -4, 0, 0, 8, and 0, 5. Or just duplicating that, it allows you to write your products, and you're going to work down first. So you're going to take the product of -4 times 8 times 2 plus 0 times 9 times 0. So do we need to do anything with that? What's that total product going to be? 0. So by giving you a number with zeros inside of it, it makes it easy for that. And then we come here, -1 times 0 times 5. So what are we going to wind up with that? Again, 0. So here's our first set. We're going to take the difference between that and let's take our second set. The second set is going to move up. So 0 times 8 times -1 is 0. 5 times 9 times the -4. And then finally 2 times 0 times 0, which is 0. Okay, so we're going to take this entire quantity here, and we're going to combine those. So here, again, you can multiply these anyway, but -4 times 2 is -8, -8 times 8, -64, minus, and then here, if you take 5 times -4 is -20, -20 times 9 is -180. And so if we combine these or add them together, subtracting is equivalent to adding the opposite. You get 180 minus 64 gives you a total of 116.